Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal prism with base edge 25 mm and axis height has been provided to us as 70 mm. This hexagonal prism happens to be resting onto the horizontal plane on its base, while one edge of the base happens to be parallel to the vertical plane. So if we locate the hexagonal prism onto the horizontal plane into this orientation, so none of the base edges of this hexagonal prism will be parallel to the vertical plane. So this orientation of the hexagonal prism is incorrect. Whereas if we locate the hexagonal prism onto the horizontal plane into this orientation, now we are going to obtain one of the edges of the base parallel to the vertical plane. So this is the correct orientation of the hexagonal prism with respect to the two reference planes, horizontal plane and the vertical plane. So now we have been provided with the information that a square hole of side 25 mm has been drilled through this hexagonal prism in such a way that the axis of the hole happens to be perpendicular to the vertical plane and the axis of the square hole is going to bisect the axis of the prism over here. So if this is the prism, we'll work out the axis. Now at the midpoint, we have to obtain a square hole over here, and another condition which has been applied over here, that all the faces of the square hole will be equally inclined with respect to the horizontal plane. So the square hole into this orientation will be located at the center of the axis of this hexagonal prism over here. So all the four faces of the square hole will be inclined with respect to horizontal plane at an angle of 45 degree each over here. So with this information, we are required to obtain the development of the lateral surfaces of the truncated prism over here. So now let us proceed to evaluate the top view and the front view orthographic projections of the hexagonal prism over here. So as the observer is going to look at this hexagonal prism from the top, so the top face and the bottom face, that is the base, they are going to coincide with each other into the top view projections, and we are going to obtain the hexagonal projection construction corresponding to this hexagonal prism onto the horizontal plane into the top view projection. Now we obtain that the 6 vertical edges of this hexagonal prism, they happen to be A1, B2, C3, D4, E5 and F6, and the edge of the hexagonal prism we have taken as 25 mm. Now we need to locate the axis of this hexagonal prism. So we need to join the points 1, 4, 2, 5 and 3, 6 over here. So the three diagonals of this hexagonal base we have to join into the top view projections over here. Now once we obtain the points of intersection of the three diagonals of the hexagonal construction over here, now the point of intersection of the three diagonals 1, 4, 2, 5 and 3, 6, they happen to be axis points O and O1 over here. Whereas point O will lie onto the top face of the hexagonal prism, point O1 of the axis, it will be located onto the base of the hexagonal prism. So having obtained the top view projections of this hexagonal prism, let us proceed to evaluate the front view projections of this hexagonal prism. So from the axis points O and O1, we have drawn the axis projection line into the elevation projection view, and we know that the height of the axis of this hexagonal prism happens to be 70 mm. So the moment we mark this axis height is equal to 70 mm. Now when we draw projectors from all these 6 points of the base and the 6 points corresponding to the top face of this hexagonal prism, So we are going to obtain 6 points in the elevation projection view at a height of 70 millimeter corresponding to the top face of this hexagonal prism. So these 6 points, they happen to be 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash over here. Similarly, once we draw projectors through all the base points, that is A, B, C, D, E, F, now the corresponding projections of these 6 points of the base obtained onto the XY reference line, they will provide us with the front view projections A dash, B dash, C dash, D dash, E dash and F dash into the elevation projection view. Further, we have been able to obtain access point O dash corresponding to the top face of the hexagonal prism. We have also been able to obtain access point O1 dash corresponding to the base of this hexagonal prism. Now, one thing we need to understand over here, that the vertical edge 6F and 5E, so these two vertical edges, they are going to lie on the rear side of the solid. So these two vertical edges, they will not be visible to the observer, as the observer is going to look at this hexagonal prism from this side. But these edges should have been obtained as 6 dash, F dash and 5 dash, E dash as hidden line projections into the front view projections over here. But we are not able to observe any hidden line projections corresponding to 6 dash, F dash and 5 dash, E dash over here. Why? Because the vertical edge 6F has been overlapped by the vertical edge 2B into the front view projections over here. So this vertical edge 2B will be visible to the observer, while the vertical edge 6F, it is not visible to the observer. Similarly, the vertical edge 5E, it is not visible to the observer, but this vertical edge has been superimposed by the vertical edge 3C into the front view projections over here. So these two vertical edges, they are visible to the observer because these two edges, they are facing the observer, whereas these two edges, they are away from the observer and behind the solid. So these two vertical edges, they are not visible to the observer. So therefore, the object line projections corresponding to the vertical edge 2B, that is 2 dash, B dash projections in the elevation projection view, they have been drawn as object line projections over here. So that is why the object line projections corresponding to 2 dash, B dash, they have superimposed or overlapped upon the dotted line or the hidden line projections corresponding to the vertical edge 6 dash, F dash into the front view projections over here. Similarly, we have got the object line projections corresponding to the vertical edge 3C over here into the elevation projection view 3 dash, C dash over here. They are going to overlap or superimpose the dotted line projections corresponding to the vertical edge 5 dash, E dash over here. So that is why we are not able to observe any hidden line projections into the elevation projection view over here. So now let us proceed using parallel line development method, the development of the lateral surface of this untruncated or uncut hexagonal prism to begin with. So we are going to start from the vertical edge 1A over here. So from 1A, the first edge we have drawn over here. Since we know that the edge length of the base happens to be 25 millimeter. So now from point 1A, we have marked another edge B2 at a distance of 25 millimeter from the vertical edge 1A. So similarly, the successive edges 3C, 4D, 5E, 6F and 1A, they have been marked at the distance of edge length equal to 25 millimeter. And another thing we should observe, all these edge lengths, they happen to be true length. Similarly, the distance between these two horizontal projector lines emerging from the top face and the base of this hexagonal prism, they will be providing us with the true length of the height of all of the vertical edges of this hexagonal prism over here. So now we have been able to obtain the development of uncut hexagonal prism over here. Now let us obtain the location of the square hole onto the elevation projection view over here. So we know that the height of this hexagonal prism happens to be 70 millimeter. Now a square hole has been drilled through this hexagonal prism in such a way that the axis of the hole, it will be perpendicular to the vertical plane and it is going to bisect the axis of the prism. So let us first of all find out the midpoint of the axis of the prism. So height of axis of the prism happens to be 70 millimeter. So the midpoint we have located at a height of 35 millimeter from the base. So at a height of 35 millimeter from the base onto the axis, we have marked the midpoint of the square hole over here. Now we know the edge length of the square hole, that is equal to 25 millimeter. And another information we have got that all the faces of the square hole, they happen to be equally inclined with respect to HP. That is, all the edges of the square represented into the front view projections, they will be inclined at an angle of 45 degree with respect to the horizontal plane. So now from midpoint, we have drawn two projector lines over here at an angle of 45 degree, so that this length should be 25 and this length should also be 25. Why? Because the edge length of the square hole happens to be 25 millimeter over here. So now we have been able to obtain the orientation of the square hole into the elevation projection view as it is going to intersect with the hexagonal prism over here. So the first 4 points corresponding to the square hole which are visible to us, those points we have labeled as A dash, B dash, C dash and D dash over here. And another thing we can observe over here, that the points of intersection of the square hole with the vertical edges 2 dash B dash and 6 dash F dash, they happen to be points P1 dash and P2 dash over here, corresponding to the front face as well as corresponding to the rear face of the hexagonal prism over here. Similarly, another 2 points of intersection here we can observe P3 dash and P4 dash. So these 2 points of intersection, they have been observed corresponding to the intersection of the square hole with the vertical edges 3 dash C dash and 5 dash E dash, corresponding to this hexagonal prism over here. So we have been able to locate 4 points of intersection over here. Another 2 points of intersection, they happen to be B dash and D dash over here. So B dash and D dash points, they are not intersecting with any of the vertical edges. Rather, they are intersecting with midpoint of the base edges EF and midpoint of the base edges BC over here. That is, this is the midpoint of BC, this is the midpoint of EF over here. So onto 2 projector lines which we will be obtaining over here into the development surface view. So the midpoint of EF we will be evaluating and midpoint of BC we will be evaluating. So corresponding to this, 2 vertical projectors we are going to obtain over there, onto which points B dash and D dash will be located. Now we want to obtain the vertical projector lines which are going to depict the location of the points A dash and C dash. Why? Because A dash and C dash points, they are obtained over here at these 2 locations, and there are no vertical edges of the hexagonal prism which are going to pass through these 2 corner points corresponding to the square hole. So corresponding to point A dash, now 1 black vertical projector we have drawn over here, and let us find out where does this black vertical projector, which is going to intersect with the front edge AB over here or the rear edge FA over here. So wherever this vertical black projector emerging from the point A dash, it is going to intersect with front face of this hexagon at point A1 and rear face of this particular hexagonal prism at point A2 over here. So now we can mark it over here. As we move from point A towards point B, so at this distance from point A, the black vertical projector we can draw as point A1 over here. That is, onto this black projector, point A will be located corresponding to the front face projection of the square hole. Similarly, corresponding to the rear face, it is the rear face of this particular hexagonal prism over here. So corresponding to the rear face, as we move from point F to point A, so as we move from point F towards point A, so at this distance from point F or at this distance from point A, the point A2 will be located on the rear surface of the solid over here. So now we can check at a larger distance from point F or at a shorter distance from point A. So a black vertical projector corresponding to the point A2 has been located over here. Similarly, point C dash, again it does not intersect with any one of the existing vertical generators of this hexagonal prism over here. So now corresponding to the point C dash, let us draw a vertical projector line and let us evaluate where does it intersect with the front face of the solid, where does it intersect with the rear face of the solid. Now this black vertical projector emerging from C dash, it has intersected with front surface edge CD at a larger distance from point C or at a smaller distance from point D. So between point C and D, now we can check between point C and D into the development projection view at a smaller distance from point D or at a larger distance from point C. Point C1 has been located into the front face projection over here. So into the front face projection, point C1 has been located. Now onto this vertical black projector, point C will be located corresponding to the intersection of the point C of this particular hole in the front face of the solid. Similarly, onto the rear surface, we'll check as we move from edge point D to edge point E at a smaller distance from point D or at a larger distance from point E. Now we can check between D and D. So at a smaller distance from point D or at a larger distance from point E, we have been able to locate point C2 over here. So from point C2, if we draw a vertical projector line over here, so onto this vertical projector line, point C corresponding to the rear surface of the square hole will be located over here. So corresponding to rear surface, C will be located here. Corresponding to front surface, C will be located here. Corresponding to front surface, A will be located here. Corresponding to rear surface, A will be located over here. So this way, we have been able to locate different positions corresponding to the artificial generators which we have obtained corresponding to points A and C into the front face and into the rear face of the solid over here. So in order to obtain all of these 8 points of intersection, we can check there are in all 8 points of intersection which are available by virtue of intersection of the square hole with the different vertical edges of this hexagonal prism over here. So these are the existing vertical edges and these are the artificial, one over here, one over here and one over here. So these are the artificial vertical edges we will be obtaining over here. So let us start with point A. So we know that point A will lie onto the black projector lines starting from the points A1 or A2. A1 means front face, A2 means rear face. So if we draw a horizontal projector line from the point A dash, wherever it intersects with the vertical black projector line emerging from the point A1, point A will be located corresponding to the front face location of the point A of the hole over here. Similarly, wherever this horizontal line it intersects with the vertical projector line emerging from the point A2 over here. So now the point A corresponding to the location of the point A of the hole onto the rear face of the solid. This is rear face of the solid. This is front face of the solid. So onto the rear face, A will be lying over here. Onto the front face, A will be lying just at the starting point. Now the next 2 points of intersection, we have already discussed that B and D points, they do not happen to lie onto any one of the vertical edges. So since they do not fall onto any particular vertical edges, so we have to work out where do these 2 points they lie into the top view projections over here. So we have discussed that they will lie alongside this axis line over here, and this axis line passes through the edge E, F and BC. So onto BC we obtain the midpoint. So the front face points B and D will be located. Whenever this axis line it intersects with the midpoint of this particular edge EF. So now onto this particular blue line, so we are going to obtain location of points B and D corresponding to the rear face. Here between the edge points B and C, we can check between the edge points B and C. So this midpoint will provide us with the location of the points B and D into the front projections over here. Onto these 2 blue color vertical projector lines, wherever we are able to obtain intersection from the horizontal projector lines emerging from the points B dash and D dash. So the 2 points we are going to obtain as B and D into the front face. 2 points of intersection we obtain as B and D into the rear face of this particular hexagonal prism over here. So again 4 points we have been able to obtain. 2 in the front face, 2 points they have been obtained into the rear face of the solid. Now the next point of intersection we are going to obtain is corresponding to the corner point C dash over here. So we know that point C dash does not lie onto any given vertical projector line of the hexagonal prism. So we have obtained 2 projector points over here. One is C1 corresponding to the front face. One is point C2 corresponding to the rear face of the solid. So here we have got point C1 and point C2. So we have drawn 2 vertical projector lines through C1 and C2 over here. So now from the elevation projection viewpoint C dash, if we draw a horizontal projector line, wherever this horizontal projector line emerging from the point C dash, it is going to intersect with vertical projector lines emerging from C1 and C2. So point C in the front face, point C in the rear face, it has been located over here. So this way corner points A, B, C, D in the front face have been located. Corner points A, B, C, D corresponding to the rear face of the solid, they have been located. Now we need to obtain 4 additional points P1, P2, P3 and P4 into the development surface view over here. Now we have evaluated that these 2 points P1 dash and P2 dash, they happen to be points of intersection of the square hole edges A dash B dash and A dash D dash with the vertical edges of the hexagonal prism 2 dash B dash and 6 dash F dash over here. So if from these 2 points P1 dash and P2 dash, if we draw 2 horizontal projector lines, so wherever these 2 horizontal projector lines emerging from P1 dash and P2 dash, they happen to intersect with vertical edges 2B and 6F over here. Please check, 2B lies here, 6F lies here. So we are going to obtain the corresponding points of intersection of these 2 horizontal projectors emerging from P1 dash and P2 dash with 2B and 6F over here. So the points P1 and P2 onto the front face they have been obtained. Points P1 and P2 onto the rear face they have been obtained over here onto 6F vertical edge. Similarly, the two more points of intersection we have with us, they happen to be P3 dash and P4 dash. Now we can check it out over here. These two points of intersection P3 dash and P4 dash corresponding to the intersection of the square hole edges B dash C dash and C dash D dash with the vertical edges 3 dash C dash and 5 dash E dash over here. So these 2 points of intersection they have been obtained. So we can check that P3 dash and P4 dash they happen to lie onto the vertical projectors 3 dash C dash and 5 dash E dash over here. So from these 2 points P3 dash and P4 dash, if we draw horizontal projector lines, so wherever these 2 horizontal projector lines emerging from P3 dash and P4 dash, they are going to intersect with vertical projectors 3C and 5E over here. So the 2 points of intersection P3, P4 into the front face onto the vertical edge 3C will be obtained. Similarly, P3, P4 points onto the vertical edge phi 3 onto the rear face of the solid they will be obtained. So now we can check all the 8 points of intersection corresponding to the square hole onto the front face. All these 8 points of intersection corresponding to the square hole onto the rear side of the solid they have been obtained. So if we join the corresponding points, so we will observe that the true shape of the square hole which is obtained onto the lateral surface developed over here, they will be obtained as star shaped projections over here. So this way the development of the true shape of the square hole has been obtained over here. So let us join the boundary over here. So we can join the boundary of this particular solid and we can check the 2 edges 1A and 4D. They have not been intersected by the square hole over here. So these 2 edges 1A and 4D, they will be left intact. Now once we have joined the boundary of this developed surface, now we can also check that the vertical edges 2B, 3C, 5E and 6F, they have been intersected by the square hole. So now these are the remainder portions of the vertical edges 2B, 3C, 5E and 6F over here. Similarly, we can also join the uncut portion of the hexagonal prism which will be visible to the observer. So this boundary will be visible and these 2 vertical edges 2 dash B dash and 6 dash F dash. So this portion will be visible to the observer. Similarly, corresponding to these 2 vertical edges 3 dash C dash and 5 dash E dash. So this is the remainder portion of the solid which will be visible to the observer from the front view. So this is all for today. So through this discussion, we have evaluated the sectional front view projections of this hexagonal prism, these top view projections of this hexagonal prism, and the development of the lateral surface of this truncated hexagonal prism which has been cut by a square hole having edge length 25 mm in such a way that this hole happens to be perpendicular to the vertical plane and the axis of the square hole, it is going to intersect with midpoint of the axis of the prism, and all the edges or the faces of the square hole, they happen to be equally inclined with respect to the horizontal plane at an angle of 45 degrees. So we are going to continue with further discussion regarding few more illustrative cases of development of lateral surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.